Welcome to the Human Factors and Ergonomics Hub, a series of educational podcasts that showcase the connection between human capabilities and good work design, brought to you by the Human Factors and Ergonomics Society of Australia. I don't know about you, but I love to drive. And what I like most about driving modern cars are the assisted driving features like reversing cameras, radar and blind spot alarms. They've made my driving much more relaxing and safer. The problem for me is that when I get back into a car without these features, I notice a significant change in my driving skills, particularly with reverse parking, sadly, and sometimes even lane changing in heavy traffic. Today, I'm chatting with Professor Michael Regan about the human factors of automated and autonomous vehicles. Professor Michael Regan, who likes to be called Mike, is an emeritus professor with the University of New South Wales, Sydney Research Centre for Integrated Transport Innovation, called RCity. Prior to that, he was the Professor of Human Factors with RCity, and before that, he was the Chief Scientist for Human Factors with the Australian Road Research Board. Mike has a Bachelor of Science degree in Psychology and Human Factors and around 25 years' experience in transportation, human factors and road safety research and teaching in Australia, France and the US. In the media, we hear a lot about automated and autonomous vehicles. But what do we actually mean by automated and autonomous vehicles? And what is the difference, Mike?
Well, that's a good question, Sharon, because there are lots of different definitions out there about what automated and autonomous vehicles are. But essentially, automated vehicles are vehicles which use electronic or mechanical devices to replace some of the human driving functions and tasks that we, perform on a day-to-day basis, and I'll mention those in a moment. Autonomous vehicles, on the other hand, are those which have the same electronic or mechanical devices, and maybe some more, but they replace all human driving functions and tasks. So they can basically drive themselves, whereas automated vehicles are partially automated and hence they can't drive themselves all of the time. And I suppose the other thing about autonomous vehicles is that they're totally independent, they're self-sufficient, and they don't need to cooperate with any other vehicles or infrastructure to be able to move around. So that's the fundamental difference between the two. In one, the vehicle's partially automated, and that's an automated vehicle. And in the other one, the autonomous vehicle, it's fully automated.
So I'm wondering if we really need automated and autonomous vehicles.
Oh, it's a good point. Just before I mention that, I was just going to mention that to get a sense for what is being automated, it's good to remind ourselves of what are these driving functions that these automated vehicles are automating. And there are about a half a dozen of them. I won't go into detail, but each of these functions, as you'd realise as a driver yourself, involves many subtasks. So automated vehicles, and if they're fully autonomous, would be automating route finding, because you've got to find a route when you're driving a car. You've got to follow a route, secondly. Thirdly, you've got to control your velocity and your lateral position on the road. You've got to avoid collisions, and we all know as drivers how complicated that is, to avoid colliding with another car or another road user, be it a pedestrian or a motorcyclist. You've got to comply with traffic laws, so you've got to stop at red lights. You've got to obey speed signs. You've got to know that you can't park in particular places. And then finally, you've got to monitor your own vehicle. You've got to monitor your speed. You've got to monitor warnings that are shooting off within the car. So I just wanted to give you and the listeners a sense for just how complicated it is when you've got an automated vehicle to build them, because they've got to do all these things. And these are all things that humans actually do quite well. And we'll talk about that as we go on. But back to your question, which was about, fundamentally, why would we want to automate, vehicles? Well, there are several reasons. And from a human perspective, there are important reasons. One reason why you'd want to automate something or a task is when it's too dangerous for humans to perform. So, in places like Ukraine at the moment, you've got, robots going out there and looking for landmines because it's too dangerous for humans to do that. So you can automate a task because it's too dangerous for humans to perform. You can also automate tasks when it's impossible for humans to perform them. Someone who's severely disabled and can't use a conventional wheelchair might have an almost self-driving wheelchair, or one that can be operated with very minimal physical activity. And so the wheelchair itself is automating the task of moving the human from place to place. Another reason why you want to automate is if tasks are difficult. So there are some maneuvers in aircraft, for example, that can become difficult, not because they're so difficult mentally, but because they're monotonous to be able to perform repeatedly. And so you've got autopilots in aircraft to take control of the aircraft, so the pilot's not having to sort of sit there continuously flying the plane. Probably two other reasons why you might want to automate. One would be to extend human capability. So, for example, we can't see around corners when we're driving cars, so there are now sensors that are being developed that can see things that you can't see because you can't see through things. So radar, for example, on cars allows you to see through cars other things that are happening ahead of the vehicle. I suppose the last reason why you might automate is simply because you can, and this is probably a bit of a worry for us as human factors people and engineers to start automating for automation's sake, even though there's no value or little value, to the human user. But life has to go on, and we have to make technical progress, and they're the reasons why I think we have automation and what has been driving automated cars. And in terms of automated cars, it's really probably to do with extending human capability and automating some tasks that are difficult. And it is a difficult task every day to go out there and not, have a collision with other road users.
Gosh, it's important, Mike, to identify that we're not just talking about cars then. We're also talking about other vehicles, and you've mentioned aids for the disabled as well.
That's exactly right. But I suppose, because I've been working in this area looking at human interaction with automated vehicles, I've tended to sort of focus on that in this podcast. But, please steer me in other directions as you see fit. I just thought I'd mention, as part of answering your first question, that there are different, I suppose you call them levels of automation. The Society of Automotive Engineers has produced a table or a taxonomy, whatever you want to call it, which outlines 5 different levels of automation that currently, some of which exist currently in some vehicles and some of which are over the horizon. And I thought I'd just mention those because your listeners increasingly, as vehicles become more automated, are going to hear these terms. And so this sort of taxonomy of automation starts with level 0, which is no automation. And that would be the case for everyday cars that are maybe at least 10 years old, that have no bells and whistles, generally older cars. And in those cars, the driver's totally in control. So probably a lot of those cars are still out there on our roads. Level 1 vehicles are described as vehicles providing driver assistance, and driver assistance systems, which have sort of emerged in even less expensive cars, in the last decade or so, include things like adaptive cruise control, lane keeping assist, even, ordinary cruise control. And who's in control of the vehicle at level 1? It's still the driver. And then we get to level 2, which is what we call partial automation, which is what I was talking about just earlier in the podcast. And from a manufacturer's point of view, level 2 is really just a combination of 2 systems, 2 driver assist systems, adaptive cruise control and lane keeping assist. And you've probably heard about Teslas. They're driving along on the freeway, and you press a button, and all of a sudden the car is staying in a lane by itself, and if it comes up to a car that's travelling more slowly, it just sort of backs off and maintains a constant safe distance behind. And so that's what we call level 2 automation, and that's out there. I've actually got it in my car. It's not. I don't have anything as fancy as a Tesla, but I've got that automation. And as someone who is a human factors person, I find it very interesting interacting with that degree of automation. And again, I'm still in control, even though the vehicle can drive itself on the highway. As far as this taxonomy is concerned, I'm still in control. The driver is still in control. I've still got to make sure that the car's doing what the automation ought to be doing. I've got to be aware of situations as I'm driving along where I know the automation is going to fail, and it's going to tell me to take back control. So I know what's going on. I'm still in control. I'm still monitoring what the automation's doing. The next level is level 3. They call this conditional automation, but the names aren't important. But this is the next step from level 2. And there are no cars at the moment that are driving around on the road legally with level 3 automation. And level 3 means that the car can drive itself all of the time, but only in some limited traffic scenarios. So it might be that in addition to being able to stay within its lane, like the car I drive, and to maintain a safe distance behind the road ahead, it could also change lanes. It could also, by itself, it could also exit the freeway. But then once it gets off the freeway, it might not be able to drive in an urban environment. And so the driver is going to have to intervene if necessary to take back control. So this is the next level of automation, I think, in our journey towards autonomous driving. There's only one car I'm aware of. I think it's the Audi A8 in Germany. It can actually drive itself, and you can take your hands off and you can read a book and do what you want, but you have to take back control if it tells you. But it's not legal for it to operate at the moment. Then when you get to level 4, this is what they call high automation. So here the car can basically drive itself all of the time in pretty much all traffic scenarios, and there are already vehicles out there that are driving at this level of automation. So it seems strange to say that level 3 isn't allowed at the moment, but level 4 vehicles are, because they only drive for specific purposes. And for example, there are 2 companies, one's called Waymo and one's called Cruise in the United States, that operate these sort of they call them robo-taxis, I think, at level 4. So with Waymo in Phoenix, Arizona, you can use your Waymo app to hail one of these cars, just like an Uber. It turns up, there's no driver in it, you hop inside, but it takes you on a predefined route to where you want to go, but you can only go along selected routes. And so the car is very good at knowing from thousands of trips along that route what the hazards are, and is capable of performing all of those functions we talked about earlier on that drivers have to perform. And then there's also another level 4 truck that's operated by a company called Gatig in partnership with Walmart over in the US, and this truck basically picks up and delivers goods. Again, no driver, totally autonomous. So that's about as far as we are at the moment. And then you've got this level 5 automation, which is the autonomous vehicle we talked about before. Fully autonomous. These vehicles are sort of at a stage where they're being developed, but there are no vehicles capable of driving everywhere at the moment, anywhere on the road, all of the time, hands off. And people often ask me, well, how long is it going to take until we get these level 5 vehicles out there in large numbers on the roads? If you ask 20 different people, you get 20 different answers. That's the issue at the moment. And as a human factors person, knowing all of the human tasks that these vehicles have to automate, all I can say is I suspect it'll be at least a decade or a decade and a half at least before we see these vehicles out there operating totally autonomously. So that's just a bit of a guided tour of what's out there at the moment and when we can expect these so-called level 5 vehicles with full automation to be out there in the real world.
So, Mike, what are the benefits to society?
That's a good question, Sharon. There are actually quite a few. It depends, of course, on how successful these vehicles are in achieving their ultimate aim, which is to drive autonomously. But some of the benefits include improved safety, by eliminating or reducing crashes between vehicles and other road users. We know that there are lots of reasons why crashes occur, but some of those occur because people are, distracted, inattentive, drunk, drugged. They simply, make mistakes. But we're prone to human errors. Not that the human errors are entirely our fault. Bad system design can create errors that cause us grief. But that's one. Predicted benefit, improved safety, improved mobility is another one. These vehicles will be able to transport people who can't drive because they've currently got physical or cognitive or visual impairments. As people get older, they have to surrender their licenses ultimately, and if they can't move around, we know as a group of professionals who focus on the human condition that this can affect them very badly, and they lose their independence, and they can die from lack of connectivity. So improved mobility for those people is very important with these vehicles. They say that there'll be reduced congestion because these vehicles ultimately will be able to drive more smoothly and more evenly spaced with other vehicles because of the radar and other systems they have in the vehicle. And with reduced variability in speed comes less congestion. Improved productivity is another one. It'll allow people to do work and other things in the car while the car's driving itself around while they're sitting there as a passenger. They can do anything now when they hop in the car. And people have also said that there'll be reduced fuel consumption. So in future, what we're likely to see is trucks operating at probably level 4 on the freeways. There'll be a human driver driving the first truck, but all the other ones behind it will just be electronically connected to that vehicle. And you could have big, long road trains, just like real trains, where each truck is sort of driving in the slipstream of the truck in front. And they found that in some studies that reduces fuel consumption by about 20% in trucks by just doing that. So that's basically it. But for our purposes today, we're really probably more focused on the issues of improved safety and mobility for humans. So I've talked about, these predicted benefits, but what are the actual benefits? And so we know for level 1 vehicles, and remember I said before earlier in the podcast that level 1 vehicles are vehicles that provide assistance, things like adaptive cruise control and lane keeping assist. And I just wanted to give your listeners just a bit of a sense for what we actually know about the benefits of the systems that we have in vehicles at the moment. So for things like autonomous emergency braking, where the car will brake automatically if it senses that there's a pedestrian or another car ahead, that results in about a 50% reduction in rear-end crashes. And this is all real data. This is actual data from evaluation studies. We know that there are around 27% less pedestrian crashes when you've got autonomous emergency braking. So, apart from talking about human issues today, from a safety perspective, it's good for people to know that this is one of the most important systems you can have in a car. So if you're going to buy a car, please do ask whether it's got autonomous emergency braking and demand to have that system, because it'll save other people's lives and probably yours. And then we've got things like lane departure warning that reduces by around 11% single vehicle and crashes and head-on collisions and side swipe crashes. And blind spot detection systems. We've got, a little light that comes on your rear vision mirror that tells you that there's something in your blind spot when you're about to change lanes. That results in a 14% reduction in lane change crashes. So I won't sort of, talk any more about this, but I just wanted to, convey to your listeners that these systems are out there. When you buy a new car these days, some of them are even mandated by what we call Australian design rules to be in the cars, and they save lives. And a lot of human factors research has been done in developing these systems so that, for example, the warnings come on at the appropriate time so that when the vehicles brake in response to another car or a pedestrian, the car brakes in a way that doesn't scare the driver or startle the driver. There's an awful lot of human engineering that goes into the development of these systems, and they work. And so in terms of, levels 3 and 4 and 5 vehicles, these are, level 3 being the level at which the vehicle can drive itself for most of the time, but you've got to take back control when it tells you to. We don't know for certain yet for levels 3, 4 and 5 what the actual safety benefits are, because there are no level 3 vehicles, legally operating on roads at the moment. We've talked about level 4 trucks and robo-taxis, but they're only operating on some routes in the US. And we don't have enough of these vehicles operating in large enough numbers on, all the different parts of the road network to actually know whether they're going to be as safe as human drivers, let alone safer. And for level 5 vehicles, as I said, they're pretty much at the conceptual stage at the moment. They're still being developed. So people can go on about all the potential benefits of all of these automated vehicles, but we really don't know. We don't have enough real life data at the moment to know exactly how safe they'll be. I did want to say a couple of things though, from a human perspective about these predicted benefits for these, more automated vehicles at level 3, 4 and 5. One thing you're going to hear a lot, and you've probably heard it already, is that people will say, human errors factor in at least 90% of crashes. And it is, at least in road transport and in air transport. And so then people will say as a sort of corollary to that, that means if you've got these autonomous vehicles, that's going to eliminate at least 90% of crashes because, 90% of crashes involve human error as a factor. People like us in our profession question and should question, assertions like that because, if you go with that, flow of argument, it assumes that automated vehicle technologies are going to be error-free and that their decisions will be flawless. But we know for a fact there have been at least a couple of Tesla crashes that have occurred because the Tesla found itself in a situation in which it hadn't predicted, or no one had predicted it would be in, or because drivers drove it, outside its what they call operational design domain, which is the area in which it's capable of operating, properly. And so, we've got humans programming these vehicles, and humans themselves are prone to error. And so, if you think about the whole chain of responsibility in developing these vehicles, and I'll talk a bit about that later in the podcast, there are humans at every level. And so, the vehicles themselves, even if the technology is perfect, may never be error-free. And then, statements like, 90% of crashes will be avoided because these vehicles will, eliminate human error and assume that, driverless vehicles are going to be capable of replicating, the largely crash-free performance of human drivers that we see out on the roads. In fact, even though the road toll is unacceptably high, I think we are losing about 1,200 people on our roads every year, and I think 20 to 30 times that more are seriously injured for life. So humans, from what I said, have developed incredible skill to be able to drive these vehicles extremely well for most of the time and safely. So we know that it's going to be a big job for automated vehicles to be able to replicate that largely crash-free performance. And we know that, in aviation, human pilots are very good at resolving ambiguities. When things happen that the designers never expected to happen, it's ultimately the pilots who have to use their mental judgment and skills to be able to get the plane out of difficulties. One of the things that I find, a bit unacceptable about saying that automated vehicles will, eliminate all these 90% of errors is that a lot of the errors that occur out on the roads are errors that can be attributed to poor design of the road transport system. Poor design of the vehicle, for example. Bad human-machine interface design that's confusing and increases workload and ultimately can induce errors. Visual obstructions. Having pillars in vehicles that take up so much space that you've got no rear vision left. Inadequate sight distances when you're out on roads and shrubs that are, sitting there obscuring signage. So a lot of the errors that occur are what we call systemic errors, systemic design errors. And so, autonomous vehicles aren't going to solve all of those. And then just to say again, and I'm focusing on some of the human issues here because they're important. I mean, that's what we're about in our profession, trying to understand at the moment. When people are driving vehicles manually, their decisions are often governed by their assumptions concerning how they expect other drivers to behave. And as I said before, we cooperate with each other when we drive. And we do that in different ways, using hand signals and looking at the eyes of other road users, even though we don't realise we do that. We do it all the time. And so autonomous vehicles are going to be able to sort of communicate with other vehicles and read the minds of other road users in the way that we do. That's especially important when we're starting to talk about communication between autonomous vehicles and, say, pedestrians. And, of course, there are ethical issues around this as well. Will self-driving vehicles try to minimise injuries just to their occupants when they have a crash? Or are they going to try to minimise harm to all of the parties in a crash? And if it's the former, then, more people might get killed or injured. And so there are humans that are designing the algorithms for these vehicles that have to make decisions about how many people are going to be killed in what conditions when these vehicles get into situations like this. And these are very much human factors issues.
We will continue our chat with Professor Regan in part 2 of this series, where we will chat about the deployment of these vehicles and the critical human factors and ergonomic issues and challenges that need to be addressed. Thanks for joining us at the Human Factors and Ergonomics Hub, brought to you by the Human Factors and Ergonomics Society of Australia, where human-centred design really matters. If you like this podcast, make us your favourite in your podcast app. We look forward to chatting with you next time.